Okay, thank you very much for joining me here. My name is Leendert van Doorn. I'm a corporate fellow at AMD, and I'm going to talk a little bit about AMD's roadmap, the strategy behind it, the rationale behind it, and I think you'll find that AMD's approach to things is somewhat interesting and somewhat unique, in part because it's largely a partner play. And the other part of it is, rather than using security as an upsell, we're actually looking at enabling this pervasively across all our products, not only our low power or fanless products, but also our desktop and our server products have the same security element all over the place. So before I go into that, I want to talk a little bit about what the trends are and the things that we're looking at. And none of these should come really as a surprise to you, but I think it's sort of good to understand where AMD is coming from, right? So everybody who's looking at the current world that's changing so rapidly notices there are basically two big growth areas. Actually, there's one, right? That's the connected computer space, or the connected device space. This is anything from cell phones, tablets, but also wearable computing. This space is going to explode to 10 billion, 15 billion. I've even seen numbers of 25 billion over the next half of this decade. So that is an enormous growth. Now, that's a low margin growth, but the volume obviously makes up tremendously for that. And then on the other side, we have servers. Every about 1,000 of these devices needs a server, so there is enormous growth there as well. So now these two trends is what we're playing into. So one is consumerification of IT, bring your own device, or basically choose your own device. Some companies are having that policy. It basically brings in this large number of devices for IT that they now have to manage. For their devices, they're not even owned. So there's no element, there's no basis for them to secure their platforms on. And of course, for AMD, this is particularly interesting because we play a lot in that consumer space. That's where most of our sales are. So the second element of it is obviously cloud computing, right? That's taking off. It's the other half of that growth that I said. A lot of security issues there. Lots of compliance and accountability issues there. And then, of course, we've got the last one, advanced persistent threats. I mean, these things were sort of the toy of computer security geeks, I think 10 years ago. I see Dave here smiling. He and I worked at IBM and had lots of discussions about ESS back in 1999, which I did on PCBA. Thank you. All of a sudden, I thought I literally was going to talk to 4 people. Thank you. So those threats have now become real, right? And they're very real. And yet back then they were real, but the economic impact of it was relatively low, and that, of course, has dramatically changed. So that's something that we, of course, we actively protect our platforms against. So, again, I feel I'm a little bit preaching to the choir here. Security has to start up. The root of trust obviously has to start in hardware. Now, that's actually not as simple as you might think. There's actually, when you look at a modern SoC, there are lots of processing elements on it, way more than just a CPU. There are microcontrollers to do things like flight initialization or flight training, so basically getting access to memory. There are separate microcontrollers that do things for power management, are actually fully programmable, and so on. So making something really the root of trust in your system is actually not an easy undertaking, but it absolutely has to be there, because if you don't, then you can get in between, and then of course it just becomes the race, and the race is over. The other part of it as well is the functions, the security functions you have per device differ, per class of device differ. So the kind of security functions you need on a mobile phone versus the ones that you need on a tablet versus the ones you need in a notebook versus the ones on a desktop versus the ones on the server, very much different. And we'll talk a little bit at the end of that, but I'll give you some examples of things that we're focusing on. But a server, for example, what you want is HSM, virtual HSM, hardware security module. What you would like on a client is, for example, authentication, visual authentication, like iRecognition or something like that, being done in a security client. Two very different kind of applications. The other thing, too, is that those requirements, those security functions, can change over time. So they're not necessarily static. You may have updates to your functions. You may have new functions that come up, payment functions that people want to introduce at a later point. So, that flexibility, we feel, is very important. The challenge that we also have is that if you look at the ISP ecosystem around security, it's extremely fragmented right now. Yeah, there are TPMs, as Steve said yesterday, right? Even he has worked with 5 different TPM vendors and needs to do something different for every TPM. Now, if you start looking at the cell phone space, it's a complete Wild West there. The whole ARM space is every vendor has done its own little bit of secure boot mechanism, its own little into security functions. It's a complete Wild West that doesn't actually want to take advantage of that. And that's, of course, a challenge. And it's a challenge for AMD because one of the things we're looking at with our solution is to actually create a partnership and work with a large, broad-based set of companies to create security solutions. We'll talk in a minute about how we go about doing that. So the general conclusion of all of this is we need a more flexible solution. So when AMD started out with its security solution, it was clear that we needed a separate security processor that runs a number of security functions, and that would vary per platform, per SKU. And it had to be embedded in the processor. It had to sit at the right side of the worth bridge, the right access to the system. You didn't want to have compartmentalized something off to the side. And once we did that, and initially we were going to do that with some weird microcontroller, we very quickly came to the conclusion it's not about creating another proprietary plane. We can't afford it. I think the industry can't afford it. Right? So this is where we started looking at partnerships. And that's what we announced back in 2012. So this was a partnership with ARM, where we basically said, we're going to adopt the ARM Trustzone model in our processors. And what it really means is we took our processor and put that into our processor. Now you can imagine, some of the string-head fellows here, so this announcement costs some excitement in the industry. But when you take a step back, it actually makes a lot of sense. There is actually an ecosystem around Trustzone. Trustzone is a brand, but there is also a growing ecosystem around it, consisting of trusted execution environments, but also applications. Trustzone is available in about 80% of the cell phone market at this point, and that's growing. That volume is growing. If you look at where are the developers, whereas most of the development excitement is on that part of the world, it's in that mobile space, which again is dominated by ARM. And so that's why it made a lot of sense for actually us to adopt that. And so I'll talk a little bit more about how we did that, what we integrated, and how that works together. So the whole point of working together is not just for us to adopt Trustzone, but also to then work with ARM and with our other partners to take that technology up into the PC space and into the server space. And of course, you've seen our recent announcements about us working closely together with ARM, producing our server parts, and obviously this all falls into that. So what does this mean for the industry? Well, I already indicated that ARM has this enormous volume of products, and we have this breadth of products. So combined together, we now have this enormous volume and breadth, plus that we're covering an area where there is enormous growth. And we, AMD, can bring this to the PC and the server space, and that's exactly what we're doing. So what is Trustzone? Just in a little bit in a nutshell, it's basically the old left-hand side, right-hand side. For those of you that have been into the space for a long time, have seen these kinds of things. I think Red and Green, some companies refer to it. But you basically create two partitions. So in that sense, it's not particularly interesting. What is interesting about the Trustzone technology is that the notion that you're running in the secure world is actually permeated throughout the fabric to all the devices. So now end devices know that, have that knowledge too. That's actually very different from in the x86 world, where typically PCI device doesn't know whether something in SMN mode or something in some other weird mode is accessing it. The only thing it knows is being accessed by the processor. That's actually very different in the Trustzone world. So the model in the Trustzone world is you run a TDE, relatively small compared, of course, to what you run as the original S in the normal world, and then you run very thin, small trusted maps on top of that. It does, of course, secure root, and it then controls what gets into that secure environment. It's not the case that you can write just a trustlet and run it in that secure environment. There is obviously a trusted service manager. There's a whole keying infrastructure around that that very tightly controls what gets to run in that environment. And that is being developed. It's not that we had to reinvent that. It actually exists in the cell phone world, so we were able to make that up. So the other important part of it as well is, so that's the hardware, and so there's a lot of established base there. And then, of course, the thing we really care about is the software, and that's standardizing around standard APIs and really getting other people to write interesting applications for the ecosystem, not just for us, but for the whole ecosystem. And so this is where your typical security ISVs come in. I mean, they have been looking, we've been talking with them for years. They have been looking at how to get into the hardware, get closer to the hardware. For them, the biggest difficulty has always been this that is completely fragmented. Right? And so that's what we're trying to drive here and really try to solve. One aspect of that is standard interfaces. Fortunately, there is an organization, the global platform. You can sort of see it as a cooperative organization to the TCG that is defining these interfaces. They're coming from the smart card business. That's where their legacy is, but they're expanding into DRM solutions. They're expanding into Trustzone technologies, TDE technologies. And so that's what we're actually a very big supporter of. We're a global platform member, and we're very much aligned with ARM and the rest of that ecosystem in driving standard APIs so that those trustlets can all be written against the same API. So you can run these trustlets now on your Android-enabled phone or other kind of operating systems that use a TDE as an underpinning, as well as on our PC platforms. And this, of course, then enables companies to do things like key vaults. There's a lot of interest from the DRM community in these kinds of capabilities, so that's protected content. All those kind of services that you need to think about. So, what is AMD doing? So as I said, AMD is putting that platform security processor is what we call it, so that ARM processor next to our x86 processor. It's the thing that is in control of the system. It's the first thing that comes up with the system. It can do a variety of things, check the integrity of the BIOS, and then it can actually let the x86 cores go from reset and start up. It also has some crypto acceleration on it, stuff like that I talked about there. It runs a certified secure operating system, so it actually runs one of those secure OSs. We'll talk about that a little bit later. It does secure boot. What it does not do, I have to re-emphasize that a number of times to people, because people are starting asking me, so can you now run hard maps on an x86? No, you cannot. That's not what this thing is intended for. Yes, you run an ARM binary inside the security processor, but it's not a general purpose processor. It's actually very tightly controlled and gets to execute inside that environment. That's where the Trusted Service Manager framework comes in. So what does the processor look like? It's actually what you would expect if you build a security processor. My background actually at IBM Research, physical secure PIPS 140-2 level 4 devices. So the very high end of this space. This was more a play of like, okay, how can we build a part that is useful enough, that gives us enough flexibility, is generalizable enough for us to address different markets and different segments, but still keep the cost structure in check. So one of the biggest challenges. And there's a set of functions that you want on there. You obviously want a reasonably powerful processor. You want to have it all wrong. Where it comes out of, that is actually in the mask itself. You want to have it all RAM, but you can isolate from anything else. And then you want crypto acceleration. And this has all the normal crypto stuff that you would expect AES and various counter modes, RSA, elliptic curve crypto, all those kinds of things along there. Hardware random number generator, and such. And then it has access to non-volatile memory off the chip. Actually, we don't have that on the chip. So that's what the part is at this point. Obviously, this is going to evolve. We're definitely looking at extensions in various ways. Yes?
Tamper resistance, right?
In this generation, there is temper resistance. So that actually is a complicated topic. There is definitely side channel protection in crypto agents. We have looked at that. Physical temper resistance, we have not done that. And that becomes really a question about it's a cost issue. But we have definitely looked at Tempest kind of things because from my experience also with active research, that is way easier to do than most people realize. So we've very actively worked on that. And similarly, SBA and EPA, those kinds of things. Okay, so what is our roadmap? So up to, although AMD has been shipping security technology since 2006, in its processor, the uptake of it has been essentially zero. And so we have had a lot of focus in the beginning on CPU-centric technologies. And the challenge, and that's around virtualization, that's obviously our late launch capabilities, I/O reviews, nested virtualization, nested I/O reviews, those kinds of things. All those capabilities exist and of course are used in virtualization. Around security, we've always had a challenge in doing that because largely the complexity of the ecosystem you have to create around it. So starting in 2013, we're actually introducing this platform security processor. So basically moves security on the site in a separate environment. We're focused very much on a few basic functions. And that's going to be what I call here really the sort of the elementary function. So this is firmware TPM that's integrated in there. It does do secure boot, and it gives access to the crypto accelerators. So those are the functions that we're coming out in touch with.
What do you mean secure?
What I mean with secure boot is basically the linkage to the UEFI secure boot mechanisms, making sure you cannot, that first boot block is in fact immutable.
About that.
Yes.
But does it do verify?
Does it do what?
Verify.
Yes. Well, it verifies the signature that's on it, and if it's incorrect, it will actually go into a recovery.
How does it make it
Basically mutable. The PSP has an ability to store its own data, right? So basically, you can store the digital signature there.
So that's where your CRTM is.
That's where the CRTM would also start. So if I were to do a TPM implementation, which we are, right? That's where the CRTM basis also starts. It's exactly the same thing. So that's the version. So when I said we're going to make the technology pervasive, we are. Obviously, roadmap reality sets in as well. And so the first part that we have coming out with this capability is this year. Next year, all the other parts will come out, and we have it across the whole client line, and server will actually come in later. Yes?
Here you said the TPM will be this year?
The TPM will be this year. And we have those parts in-house, actually, at this point. We're actually bringing things up. So I'm not exactly sure what the launch date is. Not exactly sure what the launch date is. Say it again? Yes, so the way so the security processor is on the main SoC. And so it is it's actually on the same die. It is even on the same side as all the other processors of the North Bridge, right? So it has access to everything in the system and more than the normal processor has. But that's where the firmware TPM executes, and then through the ACPI interface, they communicate with each other. So in 2014, so this is when across all our products, this is actually where we're working very closely, working with companies like Trustzone to have their TV running on it and really enable that Trustzone ecosystem around that. And this is where we're working with companies around solutions, around identity protections, anti-theft, those kinds of capabilities. We have an entire solution group now looking at this and bringing this to market in that particular time frame. So talk a little bit about what it is we're going to run into it. As I said, our initial focus is on base enablement. We obviously need to get all the hardware in. We got that now. That was a design process of about 3 years. We're now bringing the system up. We've got some of the key relationships established. We're looking at those first 3 functions. As I said, secure boot, distributed crypto accelerators, and firmware TPM. And then for next year, we're actually looking at those third-party solution enablements. And the things we're looking at is really a wide range, wide gamut of solutions, all the way from payments, anti-theft, and identity management. A lot of companies want to get some sort of widget in there so they can enter their solution, they're basically root trusting their solution into the hardware. And that's obviously the discussions that we're having, while keeping track, of course, of the things that I described very early on. Bring your own device into the focus areas. So we're looking at those kinds of solutions. Going beyond that is we're very actively looking at end-to-end stories, client and product stories. What if you can just imagine if you've got the same kind of device, the same kind of solution on your cloud, on your server side, on your client side, what can you do to link the two of them together? And what kind of additional services does that enable? There are obviously a bunch of obvious ones. Clearly on the server side, the regular audits and asset management, integrity monitoring. You can even think about things like EMC functionality in here, virtual HSN is an obvious one. So those are all things we're looking at and then beyond. So last week we actually announced a partnership with Trustzone. And what this is, Trustzone is the leader in TD, the trust execution environment. So they have, Trustzone is a combination of the security group from ARM, together with GND, together with Gemalto. Both of them are long-established TD providers with a fairly large installed base. And they have decided to come together and really work together, not only to provide a more consistent TD to their customers, but also to enable the ecosystem around that. So we make them as the preferred provider for a TD environment. That's what we're running inside of our PSP, and we're also working very closely with them on them enabling the ecosystem around that. So I'm pretty excited about that. And obviously, Trustzone is pretty excited about taking this technology from cell phones and that ARM space into the PC space. So let me get to the summary. So what we're doing is we're adding a separate dedicated coprocessor, the platform security processor, to our platform. It's going to be in all our x86 solutions as well as all of our ARM solutions. It's going to be the same solution. Obviously, we want to change the workloads and the functions, the security functions that these things have per device. But one thing that's pretty stable, pretty standard going to be across all the devices is going to be the firmware TPM, and it's going to be the crypto support, and it's going to be the secure boot. We really see those as elementary functions, and we want to bring those out across everything in our portfolio, and we're not using it as an upsell capability. We've adopted a proven technology as opposed to going at it ourselves. That has a number of benefits. Obviously, we don't get stuff that we know that works, but we also get a lot of partnerships with that. And the other thing we're doing is we're creating an open ecosystem around that. The global platform participation, the things we're doing around Trustzone is really intended to be open standards, open community that we work in. And there are some open source efforts that will be announced later on, but that will play in that same vein where companies are looking at. So the only thing I can say is last, and just with a call to arms, join us in driving that open industry standard Trustzone ecosystem. I already had a fair amount of people reach out to me during this conference and express their interest in in an application that they would love to run in this environment. So please come and see me, send me email. Happy to talk to you about that. So with that, I'm willing to take questions. Yes? Dave?
How do you handle device individualization?
How do I handle device? All these devices have their own unique ID that are fused at manufacturing time. How big? That I don't know. The right person to ask that.
What do you have TPM persistent state?
The TPM persistent state is in its ultimate volatile memory that's associated with the PHP.
It's a separate chip?
It is on separate chip, yes. It's encrypted with the, it is encrypted under a key that is held in the PSP itself.
That's how you handle all that?
That's how we handle all of the storage at this point.
Rollback.
Rollback 2 is also a rollback 2. Again, you need to talk to Rob for the rest of the exact details on that. But yes, that is looked at. Yes?
So you've got the Trustzone TEE. Is the FTPM a trustlet on the TEE?
Yes. So we actually have built our own FTPM, right? And it runs as an applet on the Trustzone TEE together with other applets.
And going forward, this is going to be AMD's FTPM always running on top of Trustzone TEE.
If there is another company that's going to produce an FTPM, right, as an applet, I'm going to look at it. It's basically a make versus buy solution. I ideally buy as much as I can. Yes?
So this is a
Sure.
What is there anticipation that end users or probably right applications of parts of it? Well, the very black dress across all clusters,
Well, so it all depends on who owns the system, right? So that's where I think the challenge comes in. Our current model is TSM for that. We're working very closely with the OEMs. TEs definitely provide a mechanism to do late binding, which of course is also controlled by TSM. So as an individual developer, if you can get your component keys, you can get into the TSM components. What is the one?
The instructions that we're going to go to my main application, but the x36, my
No, so but that actually doesn't change that much. So there is definitely a development component to it. So one thing we do get, right, by staying compatible with this ecosystem, we can take definitely the trusted side of those applications for Android, for example, because that's predominantly what it is. We can move those over, right? And if that application runs entirely in the secure world, then there is no porting cost. If you have a component, the UI component, right, that interfaces with that runs in the normal world, which is the case it has to be today, right, then you obviously will integrate it in the Windows environment, and you will have to write against those APIs. So there's definitely more reward involved with that. So, yes?
Do you have any way of attesting to the TPM part of what's on it? So verifying what you hear
So there's a secure boot mechanism within the PSP, right? So there's a little ROM that's actually in the mask, right? And that will actually boost the next bootstrap phase in, and that will boot in the TE. So it basically gets loaded in as part of that. And so if the TE is compromised along the way, it will not boot.
It is getting reported.
It gets recorded, and there's also recovery action that happens in the PSP.
So I can ask something outside
Oh, that you definitely can. What am I, and again, we need to have a more detailed discussion about that. But at one point, we have talked about interfaces that you could actually at least get some sort of digital signature back with what was in the ROM and what was in the other places. So you can actually make some external assessment of that. Yes?
the accelerators, their PSP, those going to be exposed to the NVC support ports?
Yes, depending on the geography, you should. But Yes, so there is going to be essentially an outlet that sits on the TD side, right, that allows and enables all those crypto accelerators and exposes that as a security functions. Obviously, countries where we can't enable that, we will not exploit that.
But you have to send it over, you have to send the company over to the TE side and make use of it.
It's all DNA driven, right? So what you need to do is you need to do the setup with the app, but then everything gets pulled in as DNA.
So for example, the AES accelerator, that would be an interface to
Yes.
ballpark numbers of performance.
We have none in my head. Yes, these are very strictly specified. Yes.
I think you may have said it, but the PSP is closed. You're not offering either people to create their own applications or trustlets that run either directly on it or on the TCP. And if they write a global platforms compliant trustlet, then is it the trusted services manager that's going to get that loaded so that it will execute on?
So our focus right now is very much on those base enabling functions, which we're doing ourselves, and we're working with our partners, right? The compilers are actually just a regular hardware compilers. People have been using GCC compilers. This is just a regular Cortex A5, so there's nothing magic about that. Where is the magic is that you need to get it signed, right? So there needs to be a TSM who's willing to sign things for you. That's going to need to get a signing key from TSM, essentially. And that's the part that we haven't really worked out. Certainly not for regular developers at this point.
One about the VM question.
Yeah.
VM under the cluster. So is security dependent on other different clusters and
Obviously, and that's why there's a TV, right, that is doing that isolation.
so we're relying on ISO to work cluster.
We are absolutely relying on the isolation team, yes. Yes.
Is there hardware things that make it easier to provide that isolation?
Absolutely. It's a full, long, generic GPU, MMU, everything. Right, so all its capabilities are user level, privilege mode, MMU, various sizes of page tables. You've got all your regular connections. Yes?
I think you mentioned evaluation of the secure kernel.
So that actually is something that we're looking for Trustzone. The Trustzone CTO sitting there right behind you. John, you want to comment on that?
Yeah, so people might guess we're two badges that I have on today, but I'm splitting my time between this conference and the International Common Criteria conference down the street for that very reason. So absolutely, yeah, we're very confident that our solutions can be certified. They have been certified. We've got French government CSPN accreditation, for example. We've had separation curves certifications done. The big problem for the industry right now is that there's no recognized protection profile. There's no sort of smart you can put it in saying it's a smart card because it's not a smart card. So, at the moment we're relying on lab tests. We do have things done, but it's a lab tester entity. We're working very hard with NIAC and CCRA on one side, and the platform on the other side to actually get on the form, recognise what people need to get certified.
What level do you expect?
When?
What level?
What level? So we're doing this with CCRA. So I don't know how much you know about new start common criteria. New start common criteria is eliminating the EALs. We're going for the whole package.
What's the EAL equivalent?
So EAL equivalent is roughly 3. It's a slightly better than the max. It's a slightly lower AL than that because of the availability of stuff. But not in the speech within it on a particular point. But for example, to get from AL 3 or 4, you need the source code of the chip firmware, like the group sign, which is the chip so it's a bit that license going to customer.
So let's take that discussion offline. I think John can give you lots of more information. But this is part of the reason why we actually went for partnerships rather than doing all of this stuff right now, right? Trustzone clearly has experience with this. They've done this before for some of their products in certain countries. And we're really relying on our partners here to help us with that. Yes?
So just standing back from this is a very generic kind of question. Why didn't you just take a core negative security processor? Why did you go along and use more?
Sure.
So then, there must have been some reason process there.
Yeah. So the first one is size. x86 cores aren't fairly big, and so to use one of those as a security core is actually quite an investment. So we needed a smaller core.
It would be awfully fast security process.
What?
It would be an awfully fast security process.
It would be a very fast security process, yes. It would also be a very expensive security process. So that was one reason. The other reason was that ARM actually does have a fairly well-established security framework and partnership around that in our Trustzone. It made more sense for us to actually go and join that and expand that than us developing our own and creating a third one in the industry, which we knew nobody was going to support with. So, yes?
Is it going to be possible for them to determine which applicants are actually running in this secure
DSP. Yes, so that's a function of the team. Actually, in our situation, no. So we could run some things there, but we're not doing that. Our normal world is x86. Other questions? Yes? The Northman's G certificate? Yes, my understanding is that we're going to provide that. Okay. Well, this is silence. I think I'm going to wrap up. Thank you very much.